Good day everyone, welcome to Eminent Scholars Academy. In today's class, we'll be looking into projectile and projectile motion. First, let's define a projectile. A projectile is an object, when launched or thrown into the space, moves freely by itself under the force of gravity. And the path through which a projectile travels is called trajectory. Now, to projectile motion. Projectile motion is the movement of a body in a parabolic way, that is, in a curved way. Now, projectile motion is a type of two-dimensional motion. Why is it said to be a two-dimensional motion? Because it can be considered in the vertical component and the horizontal component. And there are some terminologies that we need to know that are used in projectile motion, some of which are time, maximum height, and range. But before we look into the time, the maximum height, and the range, let's refer ourselves back to what? Motion under gravity. Do you remember this formula? We talked about V is equals to U plus or minus GT, H is equals to UT plus or minus 1 over 2 GT squared, V squared is equals to U squared plus or minus 2GH. Why are we using this plus or minus sign? When the body is going up, it's going against force of gravity. Hence, the acceleration due to gravity becomes negative. When the body is coming down, is moving in direction of force of gravity. Then it becomes positive G. Like I've said, a projectile motion is a two-dimensional motion. That means the velocity of the body that is undergoing projectile motion, that is, the projectile, can be considered in the vertical component and in the horizontal component. So the velocity in the vertical component, that's uy, is given as u sine theta. Why this theta is angle of inclination. But in the horizontal component, that's ux, that gives u cos theta. Now let's look at the terminologies used in projectile motion. The first one is time of flight. Time of flight. The symbol for this is capital T. The second one is maximum height. Maximum height. That is capital H. And the third one is range. Range. Now let's look at this one after the other. The time of flight. Now this is the time taken by a projected body to get to the maximum height and return to the ground from which it was projected. The time of flight of a projectile is the time taken by the projectile to get to the maximum height and return to the plane of projection. Now that means if it takes 2 seconds to get to the maximum height, it will exactly take 2 seconds to get down. That means the time of flight will become 2 plus 2 or 2 times 2, which is 4 seconds. Now how do we relate time of flight with this formula? Now let's refer back to the equation of motion under gravity. The first one, that is V is equals to U plus or minus GT. Now a projectile motion, that means we are using negative sign. Now this is the small letter t here is time taken to reach maximum height. So we use Vy is equals to Uy minus GT. I use minus because the body is being projected. Is being projected, going upward. Now at maximum height, the final velocity is is 0. Now our Uy is we've gotten that word at u sine theta minus gt. Do not forget, this small letter t is time taken to reach maximum height. From there now, we can make it subject of the formula by saying gt equals to u sine theta. Then our small letter t become dividing both sides by g, we have u sine theta all divided by g. Now that is the time taken to reach maximum height. Time of flight is is twice the time taken to reach maximum height. That is, time of flight, capital T, is equals to 2 times time taken to reach maximum height. Therefore, the time of flight becomes 2 times u sine theta over g. That is 2u sine theta over g. I believe this is crystal clear to everyone. In our subsequent class, we look at other terminologies.